How does the Ulam spiral reveal prime number patterns? Imagine a spiral made of numbers, starting from 1 in the center and winding outward. When you mark the prime numbers on this spiral, something surprising happens. Instead of being scattered randomly, many primes line up along specific diagonal, horizontal, and vertical lines. This pattern is what makes the Ulam spiral so fascinating. It was created by a mathematician named Stanislav Ulam in 1963. He noticed these prime-rich lines while arranging numbers in a spiral shape during a meeting. The pattern suggests that prime numbers, which are numbers greater than 1 that can only be divided evenly by 1 and themselves, are not just randomly spread out. Instead, they seem to follow hidden rules connected to special mathematical formulas called quadratic polynomials. These are expressions involving the square of a number, like x squared minus x plus 41. Some of these formulas tend to produce prime numbers more often than others. When you plot the primes generated by these formulas on the spiral, they tend to line up along certain diagonals. This is because these quadratic formulas relate to the geometry of the spiral itself. From a basic number theory point of view, prime numbers are the building blocks of all natural numbers. Understanding where primes appear helps us see the patterns behind the numbers we use every day. The Ulam spiral makes these patterns visible in a way that simple lists of numbers cannot. It shows that primes might follow some underlying order, even though they seem random at first glance. This discovery has inspired mathematicians to look for prime-generating formulas and to ask whether there are infinitely many primes produced by certain quadratic formulas. The spiral acts like a map, revealing hidden roads that primes travel along. It connects the abstract world of numbers with visual shapes, making the mysterious distribution of primes easier to see and understand. In essence, the Ulam spiral turns the idea of prime numbers into a picture, showing us that these special numbers might be part of a larger, more predictable pattern than we once thought.